Hey everybody, welcome to math class. Today we are going to continue solving quadratics. Yesterday we looked graphically at where these things cross the x-axis, which was very, very easy, right? We're just looking for where are these x-intercepts going to be. Well, today I'm going to give you a function like this one behind me, 5x squared minus 43x minus 18. And I'm not going to use Desmos. I'm not going to graph it and find out where they cross. What I'm going to do is algebraically solve this thing. So let's go back to what we know about x-intercepts. If something crosses the x-axis, we should know this from the first time that we talked about it together, that the y value is going to be 0. So if the y value is 0, for us, that means that this thing has to be equal to 0. Every function, if I'm going to solve it, has to have a 0, an equal sign. And if we think of this as like y equals this function, we know that the y value has to be 0. So that it's always going to have to equal 0. That's like our first step. It doesn't always equal 0 like to start. Sometimes we have to actually physically move something, like subtract something or add something, and get that 0, but it has to be 0 before I can actually do anything in this problem. Cool. So we set it equal to 0. And now notice that there's no kind of procedure like there was in linear functions where I can just say like, oh, add 18 to both sides or subtract 5x squared, right? Because you guys have never solved anything with an x and an x squared in it, which is pretty tricky. So we can't do any kind of procedure like that. What we would like is to see if this thing factors. That's always kind of my first step. Look at it, can I factor this function? If I can factor this trinomial into two binomials, that will really, really help us out in solving. So it looks like we have an a coefficient. So I want something that multiplies 5 times negative 18, 50, and 40 is negative 90. And adds to give me negative 43. Now, I did look at this ahead of time, and it looks to me like we're looking at negative 45 and 2. Negative 45 times 2 is negative 90. Negative 45 plus 2 is definitely negative 43. So, there is my two factors. And if you remember, we're going to have to factor this one by grouping because there's an a coefficient. So I'm going to go 5x squared minus 45x plus 2x minus 18 equals 0. We're going to do this. And in this first one here, it looks like we can take out a 5x. That would leave us with just x minus 9. And hopefully we can take something out and be left with x minus 9 over here. It looks like if we take a 2 out, we're left with just x minus 9. Cool. So we see that our two factors are the insides and the outsides. And that's all we know how to do so far. But now we have them equal to 0. So there's this interesting thing called the zero property. What's your book call it? The zero product property. Sure, zero product property. And basically that says that, hey, you see how we have two factors? Well, in order to get 0 over here, we know that one of those has to equal 0. Right? If I do some number times some other number and it equals 0, one of them has to be 0. That just has to be true. So what we can do if we want to solve this is we're going to separate these and we're going to set them both equal to 0. So x minus 9 equals 0. That's one of my choices. Or 5x plus 2 equals 0. That's the other choice. And basically what's going to happen is that's going to give me my two solutions. These are the two places when x could be 0. So it's really easy to solve these, which is kind of cool. If I want to get x by itself, we just add 9 to both sides. And x equals 9 is going to be one of our solutions. And then over here, we're going to subtract the 2. We get 5x equals negative 2, and then divide by 5, and x equals negative 2/5. I don't know if you can see that. Oh yeah, we're good. So I have two solutions, which I assumed I would. We have negative 2/5, and we have positive 9. So without actually looking at my parabola and seeing where these two things cross, I could actually solve for that mathematically. We factor it. We set both factors equal to 0 separately. We solve both, and those are our two solutions. Let's try another one. Let's try, I'm going to switch it up. I'm not sure how well you can see that orange. I think it shows up okay, but let's switch it up this time. Let's try, where'd it go? Okay, x squared plus 9x equals negative 20. And so I would like to solve this quadratic and see what kind of solutions I get. What are my x-intercepts going to look like? So the first thing I notice, I just told you this on the last problem, you have to have it equal to 0 before you do anything else. If it's not equal to 0, that's a problem. And in this time, we do not have it equal to 0. So we have a problem. So what I'm going to do is I want to make this 0. I'm just going to actually add 20 to both sides so that that will turn into a 0. This one doesn't have any like terms, so I just throw 20 on at the end, and now it equals 0. So sometimes, like I said, that's that one extra step that you might have to do. If it doesn't equal to 0 to start, we're just going to make it equal to 0. It's kind of backwards from what we usually do, right? Because usually we'd want to kind of get rid of those numbers, but this time we want it to be equal to 0. Cool. Now we're going to check factoring. Does not have an a coefficient. So I want something that multiplies to give me 20 and adds to give me 9. And you might be thinking about those options, but I noticed that it's both plus signs, so that makes our life a little bit easier. Let's go with 5 and 4. 5 times 4 is 20. 5 plus 4 is 9. So my factors, I don't have to group this time. X plus 5, x plus 4 equals 0, like so. And then all we got to do, if we know that one of those has to be 0, we set both of them equal to 0. So x plus 5 equals 0. X plus 4 equals 0. And very easy to solve here. Subtract the 5, x equals negative 5. Subtract the 4, and x equals negative 4. So this is going to be quite a skinny parabola, because the two solutions here where it crosses the x-axis are negative 5 and negative 4. There you go. So that's kind of how it's going to work every time we factor. We're going to see the trinomial, we're going to try to factor it, and once if we can factor it, we're going to set each set of factors equal to 0, and then we should be able to solve it from there. Yeah. All right, cool. Hopefully that's good. If you guys have any questions, obviously let me know so I can help you out. This is like a super important skill. You're going to use this forever, seriously forever. And you're going to have a lot of quadratics that you have to solve, and this is the way you do it. So factoring, thumbs up, good stuff. All right, later.